Well, this is where I've decided to go with this. No matter what I do, if I cut these down, I can't change that maximum diameter before reboring this. One thought I did, these look to be a bronze material because of the coloration, and I thought about boring this out. I have a piece of brass pipe. It's brass. Now, brass will probably work in this situation. It's not like it's a high load bearing, it's more surface or anything like that. And I keep it lubricated. Brass would probably work. What I could have done, this piece of brass pipe would have worked real nice. I could have bored this, put these two together in the lathe, bored this so that this fit in, and I could have silver soldered it in and then rebored it and still had about 25 thousandths walls thickness of brass on there for the right diameter of the bearing surface. And then I could have cut this again after I'd done all that work, which would have been kind of a slick repair. I also looked into buying material. Well, a chunk of material for this, I would have to buy 13 inches of it and $117. Well, that's not happening. Clean this up, and I have some silicone bronze TIG rod. And silicone bronze is used in building bearings like the cages for ball bearings and other bearing uses. So for what I'm doing, I think this silicone bronze is probably an excellent material to do some build up. We'll go through here and build this up, and then I'll put it together in the lathe like I showed you before and rebore it. We only need about, if I built this up to 30 to 40 thousandths worth, would be just fine. It'd give me plenty of material. Actually, that's just in here, and as it gets up here, it gets less and less, because up here I don't need any. It's all in just this part here. We'll build it up thick here and work our way up until it's thinner, thinner, thinner. We don't know, but we'll find out. If I screw it up, I screw it up. Then I'm buying a piece of 1/16 silicone bronze at 90 amps. This stuff is about 3/8 of an inch thick almost, and boy, it takes a lot of current here to get it to even form a puddle. But then it goes kind of fast. I think we'll let those cool and hold them together and see what kind of rough measurements we have. I might be a little thin on that one, but we'll see how it goes. Alright, cooled off and washed and scrubbed a little and cleaned up. They don't look too bad. And I think I've got enough. The only place I might be a little light is right here. Doesn't look too bad, but I might end up being light here, right there. Got a couple little inclusions here, but up in here I'm going to machine 99%, or actually probably 100% of that away, so that's okay. Other than that, not too bad. And I already cleaned up the ends. I just hit these with a file so they match up a little bit. And it's kind of round. We're going to put that in the lathe and see what we can get out of it. We have it chucked up. I put a 1/4 inch thick parallels behind it and pushed it up against there, and I cleaned up the back a little bit with a file so they're flat. that's good enough. I just wanted to get the high stuff off. So I got a nice big boring bar here with actually a round tool bit made from a high-speed broken off center drill. And we're going to start boring that and get it rounded up a bit, and we'll start measuring. Cutting really nice and easy. I'm just doing this by hand. Just kind of going to hog it out. And we got quite a bit to hog out, but that part there looks really okay. We got a big spot there and a big spot pretty much across from it, so we're going to see what we got here. We're at 1,380 and we're looking at 1,566. We're at 1,460. We have about 100 thousandths about total to go. It's 50 thousandths a side, which is going to be pretty good. We might end up with a few holidays though. This side looks a lot better. Probably should have put a little more metal in, but I just might go back and add some here. See how it looks. I changed my boring bar. This one is giving me a much better cut and finish, but I'm going to end up having to weld some. This is would be the last final cut, but I'm going to have to go back in. I had some pour bonding, and that was in the beginning when I didn't have enough amperage going, and it has some pour puddling. So I know I'm going to have to go back here, but we're going to cut this anyway. Yeah, right there. You see right here. Yeah, it didn't have enough amperage going and didn't puddle up, so it's kind of flaking off. It's so thin there. The rest of it looks really good. That's where the split is. But right there. So I'm going to have to go back in there and redo some of that. Right at 566, that's what I was shooting for. Yeah. Except for that. I'm going to witness mark this. So I put it back together the same way and back in the same way. Back together, back in the lathe. That's the spot I redid. Just at there about 3/4 of an inch worth. And hopefully we're still pretty lined up. We'll see how it goes here. Oh, that's good. I think I'll just stop right there. I can't really feel it, so after I took a couple measurements and I took one more 2/1000 depth to cut, and I'm right there, 567. Here's the finished bearing. All faced off, edges chamfered and such. Came out really nice. This side here, so here's this side. We'll just put it in there. Fits just beautiful, perfect on the radius. That's just perfect fit. Now this one here went in a little tight, so I don't think they cut it right in the center, and so the lead-in, this lead-in edge here was catching, so I just kind of chamfered a little bit extra on both of those edges so it doesn't catch, and then that fits in there just right. And I put a couple witness marks, so I had to, for the alignment how it had in the lathe, and cleaned up the ends, and we still have a nice little bit of play, which is just right. And if you hold it, it works in there good. So we're going to reassemble it, and we'll see how it be. Now this is going to be 10 times better than it was. So I hope that fixes up the vibration issues. Now this cover goes on over this part, but I'm not going to put it on yet because if I have to get to those set screws, then I'll have to move it. So we're not going to put that on there yet. Yeah, it's just a guard so you don't accidentally get your fingers or something in there when it's spinning. Okay, that's that's pretty simple. Now we're try it on the lathe. This is the back end of the lathe here with the change gears. Now on here, this is the end of the spindle, there's a nut. This is the drive nut for the collet attachment, and it's kind of been beat up. I really probably should build a whole new one. Somebody's brazed on it, it looks like. You know, I'm trying to repair things or something. Yeah, it looks pretty trashed. But anyway, I should probably make a new one of those. Anyway, there's been washers on here, and there's all these wash spacers, and this thing's barely on here, like by 2 threads, you know, type of thing. And I took a bunch of their washers out. That was when I got the lathe, and I made 1 spacer for all those washers. So now we've moved it in to those other holes, that the original like holes that were on that shaft. So that means they pulled the shaft out in this direction, out of the lathe. And we'll move that in because it sits against this. So to move it back in again, I took all those spacers out, right? And that fits really nice, actually. There's just a little gap inside here against the spindle. I think that's how it's probably supposed to have been. Got scanner on. Fire season already. There was a 500-acre fire just today, down the hill a little bit from us. So, and then last week there was a fire got away down near where they're doing the logging and down the road. So, oh yeah, they had air support and everything in there. That was on Memorial Day weekend. I think on Saturday it was. So, yeah, so I wear the scanner with me and listen for things, keep track of things going on. Anyway, so I put that nut on there. I got all my taper adapter in the 5C taper adapter in the spindle. And then this just slips right in. Pretty simple. And this piece here engages in the nut. Just like that. Now, this nut has to be adjusted because we moved it in, so this nut has to come in. What that nut is, stops the travel of the spinning piece that we did our bearing on, so that this rides right up on the top of that. So that's the lock-in point when it comes up that ramp, and then that would lock in when the collet is tight. It gives you that snap action type of setup. Just like that. Okay, well, that means you got to be able to pull on the collet. So I got 3/8 collet here, chunk of stock. So when you put the collet in, that tube screws onto the outside threads. Well, you need to catch enough of those threads to be able to pull that collet. Well, what I found is, if you put you want to put a piece of stock in when you're doing this. Otherwise, you can be falsely in a false situation where the collet gets pulled too far in. So you don't know exactly where that collet is going to sit when there's a piece of stock in it. So you put a piece of something in there. See, now I can't catch enough of the collet. There it is, right there. I probably got maybe one thread, but then I can't pull it because I'm already screwed in pulling it. So now I can't lock the collet to the snap action type set where it locks your stock. So that means the tube is not long enough. You need to have it long enough to allow you to move it that little bit to lock your stock in your collet. So that's why they moved this out. On the end of that tube, it does not look like a machine. It looks like somebody ground it actually by hand. So I'm wondering if the threads got screwed up. Somebody whacked off, I don't know, 1/8 inch, 1/4 inch, probably about maybe 1/2 inch even. Threads got screwed up. They cut it off, so now it's shorter. So that's why this has now been moved out to allow for that length to grab that collet. Now you don't want that collet to. By them doing that, there is a shoulder at the bottom of the threads where the collet screws in, and you don't want it so much that you bottom out on those threads really either. So the other option is make a new tube, which isn't happening today. I'd have to get a piece of tubing and turn it and all that. So anyway, that's not happening. So I'm going to move this back out, probably about 1/2 inch, because I'm not catching the collet. And we have a little more, about 1/2 inch, a little more 1/2 inch of thread on those collets. So that is why this has been moved out. There's really no need for the spacer. I think I can get away with the spacer as long as I move this out 1/2 inch or so, and because that's about what gap we have here, and screw it on there and try it out. Alright, so I loosened that and I moved it out 1/2 inch roughly, and I've screwed in my collet. So now, and I screwed this collar back so it comes to the right spot here. Now what I'm doing is this pin is pulled out, so it's not engaged here, and I'm tightening the collet by hand until I feel enough tension to hold my stock. If you don't have enough tension, your stock can slip on you. Anyway, then that when you get it into the spot you want it, then this pin will you just give it a 1/2 turn out of that slot, and it drops in. And you feel that, you go, oh well, is that enough or not enough? Well, right now, I'll tell you right now, it's probably not enough. You may not be able to turn it by hand, the stock, but when you're machining it, it will spin. I just know what the feel should feel like. But that's very, very close to where it should be. So you open and close it a few times until you get it in the spot you want it to be. Now, I can't turn it anymore. So what that tells me is I've probably brought this too far back because I'm bottoming on the threads of the collet. Like I said before, you don't want to have that collet bottom out because you won't have enough adjustment. So this needs to come in a tiny bit. Now, I have come across a few collets that are longer than these collets. These are just Chinese ones. But I have some Harwich and a few others, the Royals and such. Yeah, they're not always all the same length. So if I used one of those, you'd have to change this. But anyway, that feels real good right there. Now we're gonna give it a run and see how these bearings look. We're gonna probably have to adjust these a little bit. Okay, so when the spindle's running, this part is all turning, locked in. This part is stationary and spinning on that bearing. And now, so that bearing, I mean, it's just everything's spinning inside the bearing. And when you lock it out, it's still spinning. But that, see how it's wobbling a little teeny bit? And that might be that little tiny bit of run out we have in the shaft, but that is zero compared to what it was. What it was like this. That's what it was. So there's a tiny bit there. So maybe what I'll end up doing is trying to get that little bit of run out of that shaft or the tube. But that was pretty good. I mean, the idea is that when you're using the Collet Closer like this, that if you're doing production work, you got to feed your feed tube there. Like I have a pneumatic feed tube that goes on here, and it's always pushing pressure. It's always pushing that rod, and you don't have to turn the lathe off to feed stock. All you do is pop the collet while it's running. It will push the stock out to a stop, like on your turret, and then you lock it back in again. You don't ever have to grab that stock. It just pushes it automatically. But the tube is really long. It's, I want to say it's over 10 feet long. And right now I don't have the room in here to get that in here. But I could get that set up at the time. But anyway, right now I'm just using a tube and I'm just manually feeding it. But that's why you have a Collet Closer like this, where you can open and close it with the lathe running. That's beautiful how that's working. Just beautiful. Okay, so that concludes the repair on that. That's going to work out. I'll put the guard back on and be able to make some scribe to it. What a deal. We'll see you guys in the next one. So what I'm going to have to do is I'm going to have to remove some material on these faces, or on one of the faces at least. I'll probably just take it to the sander and sand off some of this on the face. But that's not going to do it either.